are now at the University Museum of Contemporary Art, this very nice space which is dedicated to the topic that we will be discussing today. We have with us Roger Malina, who is an astronomer, an astrophysicist, has been working in scientific projects for many years. And Roger Malina is also the executive editor of the Leonardo publication of MIT, the Massachusetts Institute of Technology. And he's with us today celebrating 50 years of the Leonardo publication. It's very nice to have you in Mexico. This is not the first time you'll
thank you so much. And usually when I've come to Mexico, it's because of my astronomy and astrophysics activities. But here, it's because of my activities that bridge the arts and sciences.
Yeah, thank you very much for visiting us. And I would like to start this chat by just talking a little bit about one of the projects in which you were involved, and you were one of the leading persons of this extreme ultraviolet explorer, this satellite that was trying to do a map of our universe, those objects in the universe that emit ultraviolet radiation. Can you tell us about your involvement and what this project was about?
Okay, so I'm going to start at a quite general philosophical level. So every human civilization has been interested in trying to find out, understand what's going on in the sky. Because from the earliest humans, we could study the sky, we noticed that things changed. Sometimes we thought the changes were connected to human activity, and we were trying to figure out. In the history of astronomy, of course, until the last century, almost exclusively we studied the sky in visible light, the light that our eyes can see. But then, beginning last century, astronomers and physicists realized that they could study the sky in other colors. Infrared, ultraviolet, later X-rays, radio waves. And so over the last 100 years, astronomers have been trying to map the sky in every color to get the bigger picture, because very quickly we discovered that there are things going on in the sky that we cannot see in visible light. There are things, X-ray stars, that are almost invisible in the light that we know how to see. And so it was a very exciting century, I think, from that point of view. And when I was an undergraduate student, age 18 in 1968, I was an undergraduate in physics at the Massachusetts Institute of Technology. And at that time, X-ray astronomy was just beginning. The first X-ray telescopes were being designed. At Harvard, it was Riccardo Giacconi, who later got a Nobel Prize. The competitor group at MIT, which did not get the Nobel Prize, which I was in, was Hale Bratt and Saul Rappaport. And there I was, a 19-year-old, and they asked me to work on some projects, building new kinds of telescopes, which were then launched on a rocket. So like a lot of people, I was enthusiastic about space. So they built this telescope, which I helped design. We went to launch it on a rocket in New Mexico. It went above the Earth's atmosphere for about 300 seconds only. It took pictures of what it saw in X-rays and then came down again, and we analyzed it. And there I was as a 19-year-old student in the summer, working 24 hours, analyzing the data, and we saw things that nobody had ever seen in human history.
You produced actually a map of the sky in
so that was a discovery in X-rays. Then I went on to Berkeley, where I did a PhD in astronomy. And there it was, my PhD supervisor was Stuart Boyer. And there was a little gap when nobody had mapped the sky yet, in between X-rays and the ultraviolets. the extreme ultraviolet. And so his ambition in life was to make the first map of the sky in that range of colors. And we did it. NASA funded a very big project called the Extreme Ultraviolet Explorer. We built a team of almost 200 people to work on that, designing, launching that satellite. It took about 10 years. It was difficult because the shuttle exploded, the Challenger explosion, and so our project had to wait to be launched again. So it was a very long project and not something that you could do in 1 year. It took 15 years. And we made a map of the sky in extreme ultraviolet. We made a list of about 1,000 stars that could be seen in this particular color of light. And it was part of a general strategy that astronomers have had of mapping the sky in every wavelength.
You are now a member. Yes, yes, go ahead.
But then and you're a physicist.
Yes.
We discovered that the sky is full of other things that don't emit light, like cosmic rays. Now, maybe they're just, and so during my career, we learned how ignorant astronomers are because most of the sky does not emit light. Yeah. I'm sorry, I diverted your question.
No, that's a very nice description of such a fascinating project which uses the most advanced technologies up to date. And now you are a member of the Astronomy Observatory in Marseille.
So then, after the launch of this satellite, we had been collaborating, and science, as you know, is a very collaborative discipline. We've been collaborating with Georges Gautez in Marseille, who was one of the pioneers of space astronomy in France, and Jean-Michel de Harvin. And they recruited me to be the director of the astrophysics lab in Marseille, working with in this case, not NASA, but the European Space Agency, building next generation telescopes to go into space. And so my final position was as director of the Astronautical Observatory of Marseille, Provence, which is one of the oldest observatories organized. I think it's almost 500 years old, as an organized observatory. Cassini and a lot of very famous astronomers worked there. So, yes.
So now the search is dark matter, which is also a very fascinating topic.
Okay, so they're clearly one of the biggest discoveries of the last century in astronomy is that most of the universe does not emit light. And so my joke is, actually astronomers are studying the decoration of the universe, they're not studying the universe. So it was like in this museum, all I'm studying is the design architecture, but the artworks I can't see. All I'm seeing is the furniture. And so the discovery that most of the universe doesn't emit light, for me, was a very destabilizing experience. And unfortunately, astronomers are not good at inventing words, so they called it dark matter, as if all that mattered was this matter doesn't emit light. No, this matter is interesting itself. We don't have good names for it yet. Right now we call it dark because it doesn't emit light. And we don't know what it is, but we know that at least 60, 70, 80% of the content of the universe, the majority, astronomers have been useless to understand. And fortunately, the physicists have been working on the problem too.
Yes.
And
so these scientific activities that you have, and you have actually a career in science and technology as well as your father did, somehow is complemented with activity in the arts. So you are now involved in artistic projects, and you were mentioning in your exposition yesterday about some of them. Can you tell us something about some of the artistic activities in which you are involved, some of the projects that you are involved in between science and an art.
Okay, so before I do that, let me just, no, I don't think all astronomers should be fired and unemployed, but this realization of how badly designed the human body is to understand the world. Obviously, we use the tools we can, our eyes, our touch, and so on. Albert Einstein very made a nice statement. He said, the nature of our ideas are just as independent of our body as the clothes we design are. We build clothes that have two legs because we have two legs. And so similarly, he argued that our ideas are so influenced by us that we only know how to think like a costume designer, two legs. And I think Einstein had a very good point that most scientists don't want to hear, that science is very biased because of the way that we're able to think and the senses we have. And suddenly you're in a territory where artists are also trying to figure out the world, which doesn't make sense. And so 120 years ago, when Einstein was working, and there was all this discussion of the fourth dimension, well, artists were right in that discussion on talking about multiple dimensions and higher dimensions. They were trying to imagine how to paint the fourth dimension. A very famous art historian, Linda Henderson, has talked about how we've struggled that we think of the world as three-dimensional. Isn't it obvious? It's not. It has many other dimensions, but we as human beings view it only through our bias of three dimensions. Well, artists have been struggling with these ideas of how do you understand the world which has other dimensions that our body cannot perceive. Yes. So I know that's very philosophical, but artists and scientists, I think, are working in this same territory of trying to make sense of what's going on. Yeah. Now, in the case of artists, they create artifacts that other humans can perceive to try and make sense.
So it was probably since Aristotle that we somehow separate science from art. It was in his famous work, Poetica, when he put them separate. He described the scientific activity and then the arts, and since then we have in the universities separate faculties for arts, fine arts, and culture, and then we have science. But people like you believe that they should be put together somehow, or at least there must be some intersection between science and art. Why they should be together? Why not keep them in a separate way?
Okay, so ever since there have been human beings, we have had to specialize. Because when you specialize, you get really good at something. And so in the discourse, there were hunters and gatherers. The hunters knew how to get animals to eat. The gatherers knew how to get vegetation to eat. So they specialized. And that was a very good idea. They became disciplinary experts on how to find animals to eat or vegetation to eat. Then they came home and they ate both together around the fire. So specialization is very necessary because you need experts. So in the Middle Ages, there were people who knew how to make shoes for people, and there were people who knew how to make shoes for animals. So you specialized in making horseshoes, or you specialized in making human shoes. But then when you went home, you probably ate at the same table. And so because of the nature of human beings, to do something successfully, you have to specialize. Today, we're in an environment where our universities are organized around this idea of the tree of knowledge. So over here is art, here is music, here is writing, here is physics, here is biology, here is engineering, here is mathematics. And so we are structured with these very necessary disciplines. But some problems require us to go across those disciplines. And today we call this, and it's a bit of a jargon, so we have to be careful, which is we need people who are transdisciplinary. I work in Dallas. We work a lot with the companies, and they say, your university makes brilliant engineers, but they're so specialized that they don't know how to work with the marketing department, or they're so specialized they don't know how to work with the computer scientists. You know, they're mechanical engineers. And so they say we want people who are T-shaped. Yes, they are experts at something, that's fine, or maybe experts at two things, but they also have transdisciplinary skills so they can work with other disciplines on hard problems that cannot be done within one discipline. And over 100,000 years, I think we have struggled. So in this culture or in many other cultures, the shaman had the big picture. Meanwhile, the hunters and the gatherers kept specializing.
Yes.
So now we need, and there are no words for it, we need people that have this transdisciplinary vision, just like the shamans in certain civilizations did, or the gurus in others.
Can you tell us maybe a few of the projects in which you are working so that we have an idea of concrete example of this transdisciplinary?
So here I am, my training is in physics, designing telescopes, materials. I'm an astronomer, I know how to make maps and analyze maps and figure out what the maps tell you about what's going on in the sky. But now, for the first time in my life, all my life I was paid to do astronomy, and at night I worked in the art world, secretly. I like to say I had two resumes, one in art and one in science. The science one was what I was paid for, and the art one I did secretly at night. For the first time, the University of Texas at Dallas has given me a job. I'm a professor in physics, and I'm a professor in art and technology at the same time. So I work both with science students and with art students and music students and writers. So I show up in Dallas. Someone knocks on my door. He is a biochemist, Jeremiah Gashenschmidt. He's trying to help find cures for cancer, and as part of the research, he uses bioluminescent bacteria. Astronomer knows nothing about this except what you read in the press. He said, I have a problem. The bacteria keep dying in my laboratory. Why can't they tell me when they're hungry? So we put together a small team with chemistry students, art students, music students. For the last 3 years, they have been filming these bioluminescent bacteria, and they discovered that they converted the light into sound so that you could hear them, because they're in the dark. You can't go lock yourself in the dark, but you can listen to them. And they discovered that just by listening to the sound of those images, you could tell if the bacteria were dying or not. So here's an astronomer working with a biochemist, with the chemistry students, music students, and art students.
Listening to the bacteria.
Listening to the bacteria. Now, I jokingly say we're teaching them to sing, but really we're teaching ourselves to understand what they know that we don't know. And the bacteria knows that they don't have enough food and they're going to die. You can express that through bioluminescent activity. And now we know what they're thinking, we're hungry. And I'm not saying that we're communicating with bacteria, that's not quite. But we're learning to understand what their signals mean that we didn't know what it meant.
So this is really using new technologies in order to see one problem and in the same at the same time producing some kind of
But
artistic work.
ironically, what the art students are experts at is digital media. Scientists use digital media, artists use digital media, and the biochemists didn't really know how to design the media, the digital technology, to interpret the bioluminescence in terms of other ways of knowing, and sound and vision are a different way of knowing that artists and musicians know how to do that scientists don't know how to do.
Yeah.
And so here's a reason why suddenly artists and scientists should work together. Yes, we specialize, but in this case, each brings skills and talents that the other doesn't have.
Yeah. We all know about Leonardo da Vinci. In fact, it gives the name to the publication of MIT that pushes this interaction between art and science. But we also know very famous stories, like, for example, the story about the Starry Night, this prestigious, famous, and very recognized painting by Vincent van Gogh. He produced this, this very nice picture when he was in an asylum, and some people said it is the east side view of his window. This is probably one of the most recognized paintings in the Western culture. And some people say that he was probably influenced by some images, drawings, and probably the first image that we have from this spiral galaxy. There was one French guy, Camille Flammarion, who was publishing books with illustrations of stars, and in particular of these spiral galaxies and the new structures in the sky. And some people believe that Vincent van Gogh was influenced probably by those images. But there are other stories. There is, for example, Pablo Picasso, who is famous for the Cubism. And some people say that he was very interested in science and that he was probably influenced by Henri Poincaré, who was a mathematician working in the fourth dimension. And Pablo Picasso took his advice. Poincaré's advice was that if you want to have some experience with the fourth dimension, it will be nice to make the exercise of going into the fourth dimension, and in case you achieve that, then you will be able to see the objects in all the perspectives at the same time. At once, you will see the object from all the sides. So Pablo Picasso was trying to do that, and this is the invention of the Cubism.
Okay, so
and there are so other
I'm
examples.
I'm going to contradict you. So I don't think what Van Gogh did was take these images from science and put them in his paintings. I think what the artist or the musician or the writer is expert at is training you to pay attention to something rather than something else. So if you're a landscape painter, and where I was in Marseille, landscape painting exploded with the Impressionists, where they suddenly had paint. They could go out into nature and paint parts of a landscape that nobody had paid attention to before. Similarly, I think what the artists do is just navigate and say, pay attention to this. So yes, what Picasso did, he said, yes, we make paintings of the front of people, but actually we need to pay attention to everything around them. How they look from underneath, how they look from behind. And so what Picasso trained us to do was to pay attention not just to the front of the person, but to the three dimensions of the person. And so, I think this process between the art and science is mutual influence. So yes, the astronomers discovered spiral galaxies. And Van Gogh said, yes, look at the Starry Night, but did you know that you could pay attention to other things up there that are there that you haven't paid attention to? And I like this narrative because my father, Frank Malina, He was a space scientist who set up the NASA Jet Propulsion Lab, but he was also an artist. And I remember when I was 6 years old, he came home one night, he was taking painting lessons, oil painting lessons. And he said, you know, I'm tired of painting dead fish, because they were training him to paint vegetables and apples and oranges and dead fish. He said, no, what I want to paint about is all the things that we can now pay attention to through scientific instruments. What about the landscape that microscopes show us? What about the landscape that telescopes show us? What about the landscape that X-rays show us? How do I express and pay attention to those landscapes? And so I think this earth science period right now is really exciting because there is so much we know that our senses don't tell us. And artists are saying, hold on a second, there's all this other stuff going on out there that we need to pay attention to. And so I think the artist is expert at training us to pay attention to something. What kind of sound should we listen to?
But there was always an interaction. This interaction between science and art, it was always
ever
there
since
in
the hunters
one way
and
or
the
another.
gatherers. Yeah, there were specialties, people who
Yeah.
specialized.
Nowadays we have David Hockney, who used to do great paintings, and he usually says that he uses technology, digital media, in order to produce it. He says, I produce this painting by using my tablet and using some resources that I get from Photoshop or whatever applications I can have. So there was always this interaction.
Right, and that's where we design our institutions at a given time. As I said, we have this idea of the tree of knowledge, and so we separate the artists and the scientists in our institutions. But when I was in Colombia recently, and I saw some of the paintings of Botero, and by accident, there was a painting of a tree and a painting of a forest. So why don't we think of knowledge as an ecology of knowledge, not as a tree of knowledge? Institutions are organized like the tree of knowledge. And in a tree, the branches grow apart. In an ecology, they reconnect sometimes they separate, water lands and kills part of the ecology, and then it dries and something else grows up. So how do we create in our institutions the mechanisms for specialization, but also in the tree of knowledge, but also in the ecology of knowledge, to find the places where artists and scientists need to work together because there is no other way to solve the problem?
One of the issues that always called my attention is the fact that when we discuss about science and art, technology and art, we almost all the time refer to visual arts. So we discuss about paintings, sculpture, objects that you produce and you can put in a museum and so on. But what about literature? What do you think about the interaction between science and literature, which is not a visual art in itself, but it is
so, this is where, I like to say that scientists and engineers are stupid. I happen to be a scientist and with some engineering skills, and so I recognize my stupidity. As a human being, I use sight, sound, I move around to try and understand the world I'm in. When I sit down at the computer, I close my ears, and I do stupid things that are the only way that I can understand the digital world. So yes, why don't we use, in the digital world, sight, sound? I explained the sonification of data that we do with the bacteria, but also one of the ways that we make sense of the world is taking our ideas and writing them down. Now, in the humanities, this is called embodiment, right? Moving things outside your head into a physical form. Dancers do this, right? They express things that they know through movement of dancers. Writers take their thoughts, write them down, take them from the inside of their head and embody it in something that other people can read. And so yes, in the history of ideas, writers have played a crucial role in that process of making sense of the world. Sometimes, in the last 200 years, we now call it science fiction. So we talk about a world that doesn't exist, but that might exist. And that's how young people often get their ideas. They go and see Star Wars at the movies. A writer has written a script, and then they made a movie about those ideas. And the cultural imagination of young people is shaped by artists, writers, musicians, dancers, all the people that a 10-year-old has exposure to when they don't know yet how to do mathematics or physics. So yes, writers also, and at Arizona State University, they have a very interesting program called Science and the Imagination. So how do people who work in the imaginative arts interact with science?
I wonder what you think about these new tendencies in art. For example, about performance art. In performance art, we don't have an object anymore as the central part of the artistic work. We have the subject, which is the main element. So performance art opposes the object of painting and sculpture and gives the subject the main role of the artistic work. I was wondering, in these new tendencies of the artistic activities, how the interaction of science and technology can be actually realized. So what do you think?
Okay, so I've been really excited by the day that I've spent here. First, it's really interesting to see different universities working together, but also the cross-linking between the arts and the sciences. Yesterday morning, I had and I'm going to say the privilege of watching a performance by a group of students and one of their teachers with these strange instruments making noises. And I'm still thinking about it. It was a performance. I was listening. I was watching. They were moving around. They were signaling to each other. What an amazing performance by this group of people. And I said to myself, how do we take the expertise of these young students and help teams of scientists work together? How do you synchronize your thinking? How do you synchronize your actions? How do you use all your senses in the performance? Movement, sight, sound, objects that they had built. I was very excited, and so we decided with my colleagues, Nina Zeglady and Ricardo Lofara, to give them an Emerging Leonardo's Award. Because it seemed to me what they did yesterday morning was emblematic of what the arts and humanities can contribute to science and engineering. In America, there's a friend of mine, Harvey Feinstein, who talks about the conductorless orchestra. And he has performed with musicians where the conductor disappears, but the musicians can play for 2 hours with no problem synchronizing themselves. Yesterday, there was still a bit of a conductor. So my question to myself was, how could this group of people in the next step eliminate the conductor? And for me, this is, I think, one of the exciting things right now. So Leonardo da Vinci was a genius. We agree. Our universities are stupid because they give diplomas to individuals. But today, what we need is groups of people to synchronize their activities together. So we need teams of people that behave like geniuses. And I think these young people here, maybe 50 years from now, will say, what happened in Mexico City that was so strange, where they developed this way of behaving as a team, with genius aspects. And so I had a real thrill yesterday, both because of the different universities working together, the different disciplines, the different ages, young people, older people. And so I think that's part of this territory of how the performing arts have a lot to teach scientists and engineers.
Was this famous French scientist, Claude Bernard, biologist, Nobel Prize, who used to say that art is an individual activity while science is a collective activity. You think this is over?
I think he's wrong.
Okay.
Leonardo da Vinci didn't work by himself. We only credit him with the genius. They had to invent new materials to paint with. Sometimes the pictures were so big that they had 20 people working on them. So I think this bias, yes, Da Vinci played an important role, but it was a collective activity at the time. Today, all the artists I work with, oh, I need a website to do my performance. So they find someone who's a web designer to work with them. I work with Cassini Nazir, who's an expert in what's called, in design, human experience design. What a strange idea. You can design human experience? Scientists don't know how to do this. How do you design the experience of data? Go get Cassini Nazir to teach you how to do it. How can you navigate through the data? How can you make sense of the data? We're now in a digital culture. In our cell phones, even our 6-month-old children are getting deluged with data. How do we learn how to navigate in that world? And the artists are the experts, not the scientists.
Let's go back to Leonardo. Leonardo is a peculiar publication. It puts together science, technology, and art, and it has already 50 years of being there. So tell us something about Leonardo, how it was born.
Leonardo is I could say it's a node in a network of networks. And for our listeners, I apologize for that metaphor, but I think it's very important. It ties to this ecology metaphor also. Why do we think of knowledge as a tree of knowledge, not an ecology of knowledge? When my father was trying to do art in the 1950s, he started using electricity and light bulbs and motors, and he was told, that's not art, you have to plug it in. So the group of artists and scientists that he was with decided to start a publication to talk about the work they were doing. That began in the 1950s. The publication began to appear in 1968. When he died, I took over the conductor role. This publication now, over 50 years, has published the work of about 15,000 artists and scientists. The universities were not interested in these people. They were just strange. Those 15,000 people are a bigger intellectual community than Florence had in the Renaissance. But these 15,000 people are all over the planet. Thanks to the internet, they're in touch with each other. The Leonardo publications, books, podcasts now, journals, have advocated the work of these people, helped document it. You kindly said at the beginning of the talk that it's an MIT publication. No, it isn't. Yes, MIT Press distributes the publication, they do the marketing for the publication, but the ideas and the content are from England, from India, from Latin America. And so, yes, we use MIT as a way of disseminating these ideas, but the ideas are not from MIT. The ideas are from Latin America. Some of the most famous kinetic artists in human history were in Brazil. And so, yes, we have built this network of networks. One of the tools and services we've built is publications that are credible in the university world, books that people can summarize their idea by writing about their creative work. And it's exciting how after 50 years, Now I'm working with Luz here in Mexico City. There's an emerging profession now, and suddenly nobody is saying if you have to plug it in, it can't be art. At least not in my hearing. Although I know in some places the artists are still very resistant to having to plug in your art. And last month we had an amazing conference in Washington, D.C., organized by the National Academy of Science, National Academy of Engineering, National Academy of Medicine. Who was the key person? Ben Schneiderman, who's an engineer, very well known for human-computer interaction. But within the National Academy, a cultural director, J.D. Talasek. So suddenly, the National Academy of Science, the National Academy of Medicine and of Engineering is saying, we don't know what's going on here, but there's all this amazing creative activity going on. They're inventing things, they're filing patents. Where was the National Academy of Art at the table, or the National Academy of Music? So maybe 50 years from now, the National Academies of Art, Science, Engineering, Humanities will be at the same table trying to help these emerging teams of geniuses be at the table.
In your experience in Europe and the United States, what would you recommend in order to put together or to create a space for joint activities between scientists and artists?
Okay, so one of the, looking back on the fights I've been involved in, one of the things I'm proudest of, I'm a member of the International Academy of Astronautics. Space engineers, heads of space agencies, astrophysicists. We were able to get 3 artists elected to the International Academy of Astronautics. So I hope in Mexico, your National Academies of Science and Engineering and Medicine will look at the work of these people and say, they may be artists or designers or writers, but their contributions to science and engineering or mathematics are so important, we want them in our academy. Now, I have an argument with Ben Schneiderman. He wants a National Academy of Art and Design, and I think he's still in this tree of knowledge metaphor, which I don't like. So I think it's important to bring within all of our national academies people in the arts, design, and humanities now that I think are making major contributions to science, engineering, medicine. I know this is a long process, so maybe it will take 50 years in Mexico, but if I can work with the Mexican community to help to think differently. It's not art in the service of science, it's art and science in the service of each other at different times. And that means how our universities promote the work of these people. I know here there's now some new diplomas in the universities in art and technology, very important. But now maybe in the Mexican environment we can identify the writers, the artists, the musicians that are shaping the science and engineering of the future.
So what is next for Leonardo publication, and how do you see, what is your view of the future for these transdisciplinary activities?
Okay, so
what is your perspective?
As I said, as you said, we're 50 years old as a nonprofit organization. We've been working with MIT Press to try and think about what do we do. And my first recommendation, let's close it down. When Leonardo started at the beginning, I think they sold 500 copies, which is not unusual for an art publication. At the peak, we sold 7,000 copies. Today, I think we sell 1,500 copies of the physical journal. Last year, MIT Press said to me, I don't know what you're doing, but last year, 400,000 PDFs were downloaded from the MIT Press website. They said, we don't know what you're doing. That 400,000 downloads is a business. So how do we work with these people to publish in different ways? And clearly print, yes, we will continue printing, but that's not the way people think or research. That's not how artists work. They go online and download things. They download YouTube videos. They download podcasts. Yes, they download text occasionally. They download computer games. So how do we start publishing in other modes that are now possible? The world of radio is being transformed by the podcast industry that is now emerging as a way of using the radio space to reach people. So 50 years from now, maybe we will be publishing mostly computer games. I don't know. So we need to experiment. So I call this experimental publishing, and MIT Press has been very encouraging to do experiments, some of which fail. So we now publish podcasts on the MIT Press website, Arteca. Maybe 50 years from now, this will be a bad experiment, or maybe it will be crucial. The other thing that MIT Press has encouraged us to do is to publish multilingually. Leonardo has published in English. I hate to tell you, but most of the planet doesn't speak English. They speak Spanish, they speak Mandarin, they speak Urdu. So how do we publish with the art, science, technology, Leonardo community multilingually? So maybe what we should be doing is publishing translation engines. Now, many people read and hear and listen to things via these very crude translation engines. Maybe 50 years from now, publishers will publish the best translation engines between Urdu and Spanish, translating concepts that have no equivalent in each of the languages. I have trouble with metaphors because metaphors are almost impossible to translate. You know, a shaman, a guru, you know, how do you translate these ways of thinking between linguistic areas? So maybe 50 years from now, we will publish in 300 languages. Maybe there will be new languages that have emerged. We used to be very condescending about, in French, what is called the patois. There's pure English, and then these people don't know how to speak real English, so they speak Indian English. Wrong. Indian English is a language, and maybe 50 years from now, it will be a very important language. Spanish is a world language, but I don't need to tell you the way you speak Spanish in Barcelona and here in the barrios of Mexico City is not the same Spanish. So maybe we should be publishing with the people in the local communities here in the Spanish they speak and building the best translation engines that MIT can invent that translate this Spanish to that Spanish. There'll be a new profession for translators of interdisciplinary translation. I don't think translation engines will ever be as good as humans at figuring out how you use the metaphor of physics and the metaphor of music and how do you translate a concept between musical expression and textual expression. So I think there's a new profession of translators. So maybe Leonardo, 50 years from now, will have the best translators in the planet for translating between disciplines. And the idea is not to combine the 10 disciplines into one discipline, but as we discussed before, there are very good reasons we need to specialize: hunters and gatherers, physicists, chemists, musicians, artists. But sometimes you have to be able to work together, and that means you have to be able to find ways to translate. And those young people I heard yesterday might be the translators of the future.
Roger, thank you very much for being in Mexico, and thank you very much for this very nice conversation.
So please elect some artists to your National Academies of Science,
Medicine,
and Engineering.
It's not going to be easy.
It'll take you 50 years, and that's okay because institutions change on a 50-year timescale. But thank God you have young people here in Mexico City that are changing on a 3-year timescale and not a 50-year timescale.
Thank you very much.
The professors.
Thank you very much.
Thank you so much for the opportunity. I know some of this has been a little bit academic and theoretical, but someone said something very interesting to me yesterday at the final talk. And I have to be careful how I say this. One of my metaphors, we know that 2,000 years ago, the trade routes were important. The Silk Route, the Amber Route. So merchants were traveling around the world, carrying goods. But ideas traveled on those routes too. Ideas went from China to Italy to England via the trade routes. Normally we say the trade routes, but those routes also, certainly in this continent, the trade routes from Latin America to North America, yes, there were goods that traveled, but there were ideas that traveled. It turns out on the university campus, there's a lot of drug trading. I'm sorry. This is a fact. There are trade routes. Maybe ideas travel along those routes too. So how do we look at the trade routes of today, like the Silk Road and the Amber Road of 2,000 years ago, and think how this network of networks of artists and scientists and engineers can use the trade routes of today for the transmission of ideas? So I don't think I want to work with drug traders, but how can I use their trade routes for other purposes? So I apologize for the metaphor, but I think that the artist yesterday who talked about that, he was working on the local ecology and trying to do artworks in the local ecology, and he happened to mention that in that local ecology, there was drug trade as well as bees pollinating. So how do we use not only the bees to transmit ideas, but maybe all the other trade routes in our environment?
This is a very appropriate and very up-to-date metaphor of our realities.
And maybe a little bit provocative. So no, I don't want to sell drugs. I don't want to buy drugs. But how can I use the trade routes of today to transmit ideas?
It's a very nice way of closing this conversation. Thank you very
so much for the opportunity.
Thank you.